Okay, thank you. I assume some folks are still making their way over here, but we're on a tight timeline, so I'll begin. I'm going to start by asking a fairly simple question, and the question is, have you got 20 minutes of your time so I can ask you 3 questions? So the first question, and the important one, is, would you like to ensure the longevity of your gearbox? The second question is, are you interested in reducing your cost of operations? And then the final question is, would you like to future-proof your business? If you've answered yes to one or more of those questions, then you're in the right place. I probably didn't mention, but my name's David Gray, and I work for the Oil Additives division of Evonik Industries. And the next question, I'm sure, is, who are Evonik Industries? Well, Evonik Industries are a worldwide presence. They are a creative specialty chemical company headquartered in Germany who focus on resource efficiency, health, and nutrition. With over 33,000 employees worldwide and active in over 100 countries, last year we were actually able to achieve very close to 13 billion in revenues from those 100 countries. I mentioned oil additives. Oil additives have been delivering technical solutions for the last 50 years, and more recently we've turned specifically to resource efficiency. We have recently introduced the Dynavis concept to bring resource efficiency and efficiency to hydraulic fluids. We've introduced the drive-on concept to bring efficiency to transmissions, specifically to engines and transmissions in the transportation market. And then very recently we've introduced the NUFLUX concept. The NUFLUX concept brings efficiency to industrial gear oils and wind turbine gear oils. And today we're going to focus specifically on that area. If we look at the broad market, the growth in the industrial oil market has been very, very steady, and in fact the forecast until 2020 is quite steady. However, the synthetic industrial gear oil market is growing quite rapidly. If you look at the overall market, it's going to increase from approximately 800,000 metric tons to 850,000 metric tons by 2020. However, the synthetic industrial gear oils will grow from 48,000 metric tons to 68,000 metric tons in that same time period. That's a 33% growth for synthetic industrial gear oils, or another way to look at that is, you could actually say the entire growth of the industrial gear oil market, 40% of that will be synthetic industrial gear oils. As such, it's a very important area to focus on. So what are the drivers for growth? More severe operating environments. I'm sure every year everybody is told that the gearbox they're using or the application they have is a more severe environment. Smaller sump sizes, there's less lubricant to lubricate the moving parts. High loads, temperatures and speeds, and that's a product of the new equipment. Routine maintenance is becoming much more difficult. As such, the expectations are for longer drain intervals. You really don't want to spend a lot of time maintaining your equipment, so the lubricant must remain functioning for a longer period of time. And additionally, there are expectations for higher efficiency. It's very important to have an efficient product in your gearbox. If you add all of those requirements together and these drivers, what do we get? Well, we essentially get wind turbine gearboxes, because wind turbine gearboxes exhibit all of these concerns. Let's drill a little bit deeper into wind turbine gearboxes. What's really important there? You have to protect the bearings to ensure long gearbox life. You have to prevent the gears from micro-pitting, and you've heard in earlier presentations today that's a genuine concern. You really need the fluid to be oxidatively stable so that the fluid lasts the length of the gearbox. And also you have to have strong low temperature performance. The other thing that's not commonly known with a gearbox lubricant is you don't need to actually affect negatively other areas of the gearbox. So it's critically important to protect the seals, the coatings, and the other materials in the gearbox that are not the gears. So what goes into a typical synthetic industrial gear oil? Typically you have a performance additive package which provides fatigue, wear resistance. It also provides protection from foaming. It provides excellent filterability and seal protection items like that. In addition, you typically have a compatibilizer. This is in order for the performance additive to stay in solution. Finally, the base fluids, and in a synthetic industrial gear oil, the dominant product here is PAO or polyalpha olefins, are used to hit the viscosity targets. Typically there's a lower viscosity and a higher viscosity product. As that breaks down, as I said, 2 to 5% performance additives, between 10 and 20% this compatibilizer to allow the additives to remain in solution, and the balance is made up of typically 2 PAOs, a lower and a higher viscosity grade. So why use a synthetic industrial gear oil? I mentioned earlier on that we're looking at increased oxidation stability requirements. Well, synthetics provide that. They provide enhanced cold temperature performance. They provide longer drain intervals. And they have a wider range of operation over a wider range of temperatures. And they have an improved fluid film. As I mentioned earlier on, micropitting is a concern, and maintaining a strong fluid film improves the microfitting performance of the gearbox and the gears. So at this point, you're probably asking yourself why all formulations are not synthetic. There are some compromises that go along with this excellent performance. So we'd like to introduce today NUFLUX. This is an alternative approach. The NUFLUX platform combines high-performance, high-viscosity base fluids in combination with formulation and application expertise, in addition to services to both the end users and the marketers of these fluids. And very specifically, the NUFLUX wind turbine gear oil combines high-viscosity base fluids with high-viscosity hydroprocess group 3 base fluids and performance additives. If we compare side by side 2 lubricants formulated to an ISO viscosity grade of 320, which is very typical for a wind turbine, you'll notice that the PAO formulation and the NUFLUX formulation have similarities, and they also have differences. Both require performance additives, but that's where the formulation changes. The PAO-based formulation requires the compatibilizers, which are needed to ensure that the additives stay in solution. Additionally, 2 different PAOs are typically used to hit the viscosity targets. In the NUFLUX formulation, you'll note there's no need for the compatibilizers, as the base fluids themselves are excellent solvents. So all that's required is the high viscosity base fluid, in addition to the hydroprocess group 3 base fluids. So as you can see, they're very similar in some aspects, but very different in others. If you want to compare all of these in one place, I thought of lots of different ways to present this, but I'm trying to compare 3 different products, a typical mineral oil, a PAO-based fluid, and the NUFLUX fluid, and I'm trying to compare 5 parameters. I'm trying to look at the total fluid cost, I'm looking at the thermal efficiency, the bearing protection, the protection from micropitting, and the additive compatibility. So what we did is we plotted everything on a radar chart, and I'm not sure if you can see the gray color at the back. I'm not sure if it comes up very well, but the gray color represents the mineral oil. To explain this chart to you, it's a relative ranking. The further to the center you are is least desirable, the further to the outside is most desirable. So as you note there with mineral oils, it's highly desirable in terms of fluid cost, but it has some severe compromises in terms of key performance parameters such as thermal stability, bearing protection, micropitting protection. It is, however, a very good solvent. If you now turn your attention to the PAO and the NUFLUX technology, you'll note significant improvements in thermal protection, significant improvements in bearing and micropitting protection. Where PAO and NUFLUX differ is their intrinsic cost and their intrinsic additive solubility. We have extensively performance tested the NUFLUX technology. We have tested in a range of industry standard tests. We have looked at bearing wear, we have looked at fatigue, we've looked at gear scuffing, in addition to more common testing such as foam, filterability, seal and compatibility testing, and others. However, what I'd like to do is talk very briefly about some of the more interesting testing. Some of you here may recognize that these are the gears from an FZG rig, and the FZG rig is a very versatile rig which can be used over a wide range of temperatures and applied pressures to simulate a number of conditions in the field. What we're actually able to do in a gear rig is simulate concerns from scuffing, from load carrying capacity, and even efficiency. And what you're looking at here is essentially 2 gears. One of them is preloaded, it drives the second gear, and you're actually able to pull the gears apart after different load stages and examine how well they're performing. The gears are immersed in a fluid bath, so you're actually able to compare fluids directly. One such test is the efficiency test. What we're able to do is apply a torque meter to one shaft, so you can compare the applied torque to one gear to the delivered torque from the second gear. Simply speaking, you can look at how much power you lose transferring through one gear to the next gear. If you look at the top graph at 30 degrees C, the top line represents mineral gear, whereas the next 2 lines represent PAO and the NUFLUX technology. And you'll note that there is a directional improvement, first to PAO, which performs better than the mineral oil, and then to the NUFLUX technology. At 60 degrees C, at higher loads, you see a very similar performance difference, that both the PAO and the NUFLUX outperform the mineral oil significantly. And what does this really mean? It really means that the fluid is more efficient, and I heard in an earlier presentation today that transmitting power efficiently is critically important. If we look at load carrying capacity in another version of the FZG test, what we're able to do is run over a series of load stages, and the thing to note here is that temperature is listed on the left-hand axis, and you'll note that the mineral oil has higher temperatures of operation at the higher load stages. What does this really mean? It really means that using PAO or the NUFLUX technology, you're actually able to significantly reduce your temperature in your gearbox. And there is a direct correlation between oil temperature and oil life. So this is a significant measure to increase the longevity of the fluid and the gearbox. Another thing we can look at, and again I noticed in an earlier presentation, that friction is important here. We run a small piece of equipment called the mini traction machine, and what it does is it measures traction coefficients. Now in some applications traction is important, but what we're looking for here is reducing friction. So what we're actually plotting here, essentially towards the bottom of the graph is low friction, towards the top of the graph is high traction. You can actually see that the mineral oil actually has much higher friction than both the PAO and the NUFLUX technology. And that is something which again corresponds to much better power transmission and more efficiency and lower heat. Micropitting is critical, and you hear lots of conversations about micropitting. Micropitting is a phenomenon that occurs in hardened steel bearings and gears under very high loads. It results in very small pores and cracks at the surface, and it will eventually result in profile change, loss of material, and catastrophic failure of first the gear and then the gearbox very closely after. So it's absolutely critical to formulate a lubricant which provides good micropitting protection. We've had our lubricant tested at the leading laboratory in Germany, and we've run both the endurance and the step test, and we've achieved the highest levels of performance. The levels of performance you would expect with the PAO as well. So you've seen a lot of conversation about running oils in benches. Well, we've spent a lot of time running them in the field, with field trial approvals from Aventus and Winergy, an approval from Siemens MD, more commonly known as Flender, and meeting the specifications of Schaeffler, FAG and others. Our lubricant partners have enjoyed significant time in the field in service fill applications. Uninterrupted service is ongoing. Very brief presentation. Time for some conclusions. Synthetic industrial gear oils are a growing sector of the market. In severe applications, they offer enhanced durability and protection to the equipment. Traditionally, these fluids have been limited to polyalpha olefins and polyglycols. NUFLUX offers a synthetic formulation approach at the highest levels of performance. At the beginning of the presentation, I asked you 3 questions. I don't know if anybody remembers them, but I'll put them back up again for you. Would you like to ensure longevity of your gearbox? Well, by reducing temperatures and protecting the bearings and the gears better, you will ensure the longevity of your gearbox. Would you like to reduce your cost of operations? Critical point here is that this formulation approach offers significant advantage over some of the more traditional synthetic approaches. And finally, would you like to future-proof your business? By working with a viable supplier and a viable technology, I think you're able to ensure that your current and future needs are met. As I said, a very brief presentation. Thank you for your time, and I'd like to invite some questions. Thank you. I will get a microphone to you. Do we have a microphone for the gentleman here? Absolutely.
Hear me now? Okay, great. Could you just explain a little bit on how the oxidative stability, how your oil achieves a greater output in terms of oxidative stability?
The oxidative stability is comparable to the other synthetic formulations, but exceeds that of the mineral oils. We actually work with a supplier of a high-quality additive system, which in combination with our synthetic base oils provides high levels of oxidation performance. We run all the industry standard testing, so the testing which is currently required by the manufacturers we have run. And we have actually achieved some approvals as well which contain oxidation testing. So, thank you.
How do the MTM mini traction machine results on NUFLUX compare to the other two products, and how does that relate to the terribly damaging start and stops that wind turbines experience?
Have I gone past it? Yeah. Excuse me. Sorry. That's a very good question. The start-stop is something we're very concerned about. We've obviously tested at two different temperatures, and as you're probably aware, the wind turbines don't typically operate at 40 degrees C. They operate a little warmer than that. So what we find is that we have lower friction at lower temperatures, and the PAO and the NUFLUX product perform very, very similarly. So we would say they're comparable. So in the same way that the traditional synthetics actually provide better fluid films at lower temperatures, the NUFLUX technology provides an excellent fluid film at lower temperatures. But in respect to start-stop, I don't believe there's an industry standard test for that currently. It's an interesting thing to look at, actually. I think if somebody could come up with a start-stop test, that would be very interesting. Thank you.
So I think you said Flender Siemens approved?
Yes, Flender
Okay.
approval, yes.
The other question I had is, have you started to look at it with other viscosity grades, or looking at it maybe in other industrial applications besides just wind turbines?
Yes, obviously we're working on that, and as you're well aware, in the wind turbine industry you have to spend a long time proving in the field, so we're well on our way so far. As I say, we've got a couple of years under our belt with the 320 grade, but that is something which is on our radar. It's very exciting technology, and we're bringing it through as quickly as the industry will allow, I think is a good way of saying it, because some of the tests are very time consuming. Yeah. But again, we want to make sure that we have all the credentials behind us when we launch the products. So,
okay.
Thank you.
Evonik. Power to create.